And then you can actually do, instead of only grabbing the last one, I want to grab this the column that's going to be, so this is -1, -2, -3, right? So that's how you can actually slice a list. So I want to grab this column, so that's how I got to this -3, right? I want to map x to a tuple of x -3 and then float of my x -1. So this is how I can actually get only the state, right, and getting rid of everything else. So only to almost like select the state and then the revenue amount. And now I want to use reduce by key, which is another function that you can use, right, in Spark. So up to here is all the same, right? Map. So now you have this list of tuples, right? So then you can do dot reduce by key, and then you can put lambda of amount 1, amount 2, map to amount 1 plus amount 2, and do dot collect. So the input to this reduced by key is actually a tuple, right? And then when you do this, lambda of amount 1 and amount 2, it's going to know the first thing, right? It's going to know that you want to reduce this. So the first one is going to, the first element is going to be treated as a key. So you want to reduce it by key, right? And then that means I want to aggregate by this first column, right? And how do I want to do the aggregation is actually is just by add them up like this, right? So if you run this, you can actually see that C8, right, it's treating the state, the first column, right, as the key, right, that it wants to use to reduce. So think of it as like if it's C code, then it's going to be what you're trying to use to group it by. And then if it's pandas data frame is, PD, like a df.group by, right, what you pass inside this group by, right? So that's like the key that you want to, by using this, it will always recognize this first thing, this first column as the key that it's going to be using. So, right, so what if I want to do something like, times, right? This will give us, right, this will give us like 300 times 750, right, to get the value for WA, and CA is going to be like all the numbers, the product of all the numbers. But that's not what we want. We only want plus, right? So this will give us a summation by each state, right? So this is actually a very important concept. Okay, so then we want to find out, the state, find a state with the highest total revenue, right? So we have all this, but what if we only want to print out, sort it by the total revenue, right? So up to here is going to be the same, right? Reduce by key, but remember we have this another transformation that's sort by, right? Dot sort by, and then we can do a lambda of state amount, right? And then to state amount of 1. So we want to, what we want to do is we want to sort it by the second element. Remember, what we're putting in is really this tuple again, right? But what we want to sort it by is actually the first. So this is our first position, which is going to be 0, and this is the second position, which is going to be 1, right? Because remember, the list slicing of the list, it starts from position 0. So if we want to actually sort it by this value, right, this revenue value, that means we'll have to do amount. We want to map amount, right? State amount to state amount of 1. That means we want to use the second number, right, as a sorting field, right? And ascending is equal to false, right? What if we do, then this is how we actually get this, right? So WA is the highest, right? You have the highest total revenue, and CA is second, or is, third. So, but then what if we want to do something like, okay, so I don't want to sort it by the total revenue, right? I want to sort it by state, right? So we can actually just change this to 0. And then this will give us, yeah. So it's going to be ascending, that it's actually going to be alphabetic, but it's going to be descending. So WA is going to come up first, right? So we can actually delete this. Then we can actually look at, it's going to be, yeah, C, it's alphabetic order, so it's going to be the first and second and fourth. But it makes sense to actually sort it by total revenue, so we can actually do it this way, right? So that's great, and you can collect, or you can, what if I want to do mean of it, right? So the mean of that, yeah, it wouldn't work in a way that because we are selecting, because the input to this is actually the entire tuple. So what if I just do map, right, of lambda, and then x to x of, 1, right? So I only want to output this number, and then do the sum, do the mean or do the sum, right? And then this is to just change the line. Okay, so this, you can actually get the mean, or you can get the sum, right? So this will give me the sum. So 730 plus this, all the sum. Yeah, it looks right. Okay, so that's pretty much it. And then we can actually do a quick exercise for like word count, right? So what if you have like all this using the same input file? You have all these like hello world, another line, So I want to count the words, right? So this is actually a very popular problem. So the first thing, right, we will parallelize our text, right, our file, and then we want to flat map it. Remember, this is the key, right? So it's going to be a list. It's not going to be a list of lists. And then dot map. So this is to say, actually, this is pretty important in a way that we want to assign a number to every word and then use word as our key, right? So this will give us hello, tuple of hello, and then one world hello, and then one, and then another, and one, right? So it's going to convert all the words to tuples with this one, right? And then we can actually reduce by key. Now the key here is going to be the word, right? And then we'll do the same thing, count 1, count 2. It doesn't matter. You don't have to do count 1 or count 2. You can actually do just A and B or X, Y, right? So this is just a variable that you assign, and you can do the summation of it, and then this you can then do the collect. So let's take another look at this, right? So we can do something like this. So we know how this looks like up to this point, right? So we can assign RDD into this. So RDD is equal to this, right? So let's look at RDD. So we can actually do dot collect. Okay. So you can see that because how we have described FlatMap is going to give us lists, right? It's not going to be a list of lists. Now we can assign this to RDD2, say, right? Not collect, just the RDD, and then we want to do is RDD.map, right? And then lambda, again lambda, and then word, and then we want to map this to a tuple word, and then it's all just one. Right, so and then we can actually do dot collect, and then we're gonna assign this to RD2 later. But and then you can actually see word 1, hello 1, world 1, another one, that, right? So then we want to assign this to RDD2, right? So it's a list of tuples. Okay, now that's good. And then what if I want to do then RDD2 dot reduce by key, right? You can actually auto tab it into autofill it, and then what I want to do is lambda of A, B, map to A plus B. How it knows, because the key here is that you have to put your key as the first element in this tuple, so that Spark will know that that's going to be the key that you're going to be using to reduce, right? So what if I do this and then do collect, right? So this will give me, you can actually see, okay, let me just print out RDD2 as well so that you will know RDD2 dot collect, right? So RDD2 dot collect is just like, you have, another appears many times, but it's every time you're actually doing another and one, right? But in here, reduced by key, you can actually see another is actually being aggregated, right? So it's like 1, 2, 3, 4. It has like 4 counts. It has 4 tuples. Therefore, it's gonna be another is being 4. So that's how you can use reduce by key to do the word counts, right? So let's say we want to assign this to, that's pretty much it. We can assign it to RDD2 or just do the collect, and that's the same results as, as in here. That's pretty much it, all, the key concept, right, of using the key functions. So we covered map versus flat maps, and then as well as reduce by key, as well as writing, some data into a text.